So today's topic is how to speed up your labeling with the Label Studio machine learning backend. We'll be featuring YOLO in this one, which is one of our more popular ML backend integrations. But Micaela will really dive in and teach you a lot about how to build your own integrations, how to use the existing templates that we have. So anyway, without further ado, I'll pass it over to our machine learning evangelist, Micaela Kaplan, who run the rest of the workshop.
Thanks, Nate. Hi, everyone. I'm Micaela. I'm the machine learning evangelist here at Human Signal. And today, as Nate said, we're going to talk about the machine learning or ML backend. Can everyone see my screen, Nate, before you jump off? Does that look good to you?
Yeah, I mean, I see ML backends still.
Perfect. That is what you should see. Thank you. I
Perfect.
appreciate the engagement. And as Nate said, any questions you have, drop them in the chat, drop them in the Q&A. I'll do my best to monitor both of those as we go. So what is the ML backend is the first question. Basically, the ML backend is a way of connecting any model that you'd like, of any format, of any kind, of any use, to Label Studio. Basically, what you do is you create a server, we often use Docker, to run your models that you'll connect to Label Studio, and I'll show you how to do that in a minute. Label Studio will then call your container on the fly during annotation to get your predictions, which humans can then verify and correct. I've linked, you'll get this slide, there's only 2 slides in this presentation, but you'll get a slide deck after the webinar that links to our GitHub repository where all of the ML backend things are stored. Also, a video explanation of some of what we'll cover in the webinar is also linked here for you. And in this image, it's kind of hard to see, but we have a list of all of the different ML backends that we have already implemented for you. These should work off the shelf in most cases. You might have to provide a couple of details, but we'll show you how to do that. And if you ever have any questions about the ML backend, I would encourage you to reach out on our Slack channel for support there. So before we dive into what makes up an ML backend and how to use it, I'm going to show you what it looks like in practice using YOLO. So as you can see, I already have this project set up in my Label Studio instance. It has a couple pictures of cars. And if we go to our settings and we go to model, you can see that I've already connected my YOLO model here. What I've done is I've gone ahead and run it locally in my terminal using Docker Compose up and providing a few key environment variables that I'll explain later. And I've also used an ngrok container as shown here to create a tunnel from my local instance, my local machine, to my Label Studio Enterprise, or to my model such that my Label Studio Enterprise instance can see it. So if we go back to YOLO, our YOLO project here, in this project, we are labeling cars and people. So we can go ahead and either label all tasks, or I'll just click into this task here. And you can see on the back end, if we look at what our model is doing, our model is run prediction, and we have populated for us automatically the different cars that are shown here. For some reason, it seems to not have predicted which class we're in. My guess is that's because they're not set up to predict more than one item. But you can see that the cars, for the most part, have been labeled here. We can go ahead and make edits if we want. The YOLO prediction is here for us, pre-done. We can't edit these predictions because predictions from the model are not editable off the bat. We don't want to edit the original prediction from the model because you want to know what the model has actually predicted. But it also pre-populates for us an annotation that I can go ahead and change. So let's say we wanted to add this other car here. I can go ahead and draw a bounding box. It adds it. I can then click submit. And it will save all that information for us in a way that is very easy to use off the bat. If we jump over just briefly to our GitHub repository for this YOLO example, which I'll go through in more depth in a minute, you can see that our YOLO example has already implemented for you a whole bunch of different types of predictions. So here we use the rectangle label object detection, but we also support object-oriented bounding boxes, image segmentation, image classification, pose detection, as well as some video tags as well out of the box. So let's dive into sort of how the magic happens and how this all works. I'm going to go back to my presentation just for a moment. For this demonstration walkthrough, we're going to use a different package. We're going to use the GLiNER example because it's a little bit more straightforward in its implementation because it does fewer things. But the general structure of an ML backend is going to be the same regardless of what you're using. So these are the files that you'll see in a basic ML backend implementation. The first one is this Docker file. If you've used Docker before, this Docker file will be very familiar to you. If you haven't, Docker file is what allows Docker to create an image based off your specifications. You import a base package, you can install all of your requirements and set up your WSGI server all in one very templated format. If you're building your own, you might need to change what packages you install here or what base image you're using. But otherwise, you shouldn't really need to touch this file at all. Relatedly, the next file that we're going to pay attention to is the docker compose.yaml. This is where all of your environment variables for your Docker container will go. Importantly, in this file, you'll need to add your Label Studio URL, which is the URL of your Label Studio instance. If you're in one of our cloud instances, it's probably app.hardtext.com. If you're hosting it locally, it's probably localhost 8080. You might need to do host.docker internal 8080. But again, these are all specifications that are very clear in the documentation, as well as your Label Studio API key, which is available in your Label Studio profile. If you click on the circle with your initials on it in the right-hand corner, it's in that menu. I'll show you where that is when we go back to Label Studio in a moment. Otherwise, you shouldn't need to touch anything in the Docker Compose YAML file, but you will, if you're using one of our implementations, need to add those two variables to your Docker Compose before you run one of our instances, or else they won't work. Next, we have the requirements.txt file. Again, if you're using one of our off-the-shelf instances, you won't need to touch this at all. If you're building your own, this is where all of your required packages will go. Works just like a regular requirements.txt file. Next, we have our underscore WSGI.py file. On the back end inside of Docker, this is run as a WSGI server. You don't need to worry about any of this really. If you're building your own Docker image for your own model, you'll need to change the name of the model in this class, and otherwise you can leave everything exactly as it is. Finally, we have model.py, which is where all the magic happens, and we'll go through that in just a minute. That's sort of like your overarching structure of an ML backend. And if you go into our Label Studio ML Backend repository here, this is on GitHub. I'll go to the main page for you. You can see a bunch of information about quick starting, how to use the Docker containers, the models that we have, all of that good stuff is here. If you click into Label Studio ML and you click into examples, you'll get to that list of all the example repositories that we have for you, including YOLO, also including things like Spacey, Segment Anything, LLMs, GLiNER, Flare, Grounding Dino, Easy OCR. The world is really your oyster here. Ooh, I can absolutely slow down. I am so sorry. All right, so let's go into our GLiNER example here. GLiNER is an NER model. It's a BERT family model. It's from Hugging Face. I'm going to use this as an example because it is a little bit more straightforward of an implementation than YOLO is, and therefore a little bit easier to follow. But all of the key pieces are going to be exactly the same. So we can start by looking at some of the files we're not going to need to edit here. So our Docker Compose file, or Docker file, looks just like every other Docker file. Again, if you're running one of our Label Studio, like one of our pre-configured files, you will not need to edit this at all. Docker Compose is where all of your various environment variables will go. Down here in lines 33 and 34, you can see the environment variables that I mentioned earlier about needing to fix. Your Label Studio URL, again, if you're using it locally hosted, you're going to want to use host.docker.internal. This has to do with the fact that if you're running a Docker container for Label Studio and a Docker container for your model, the two Docker containers don't have the same local host. And so using localhost there is not going to work. So you need to use host.docker.internal instead, which will route it to the same localhost as the one that the Docker container is being hosted on. That's a little confusing. You don't need to worry about it too much. If you're hosting it somewhere that's not locally, you'll just go ahead and post the URL to that here. So maybe if you're hosting Label Studio in the cloud, or if you're using our cloud version, you'll post that link here. And this Label Studio API key, which is left blank in our example repositories for security reasons. If you go into Label Studio and you click on your circle with your initials and you go to account and settings, if you scroll down, you can see that there is a personal access token as well as a legacy token section. which you can go ahead and use. I'm not going to show you my legacy token because it would be a security risk, and I don't want to get in trouble today. Yes, the video of the webinar will be shared after the fact, so you'll be able to find that. So let's dive into our model.py file here. You can see that we do a lot of imports. Yes, this is a great question that I see coming through. Is the ML backend available in the community edition? Yes, it is. So this will all work the same whether you're an enterprise or community edition. It's a great feature to have. I think it's really valuable. Great question. So we have this model class here. In this case, I've called it GLiNER model. It extends a class called Label Studio ML Base, which we import from the Label Studio ML package here. You need to make sure that you do this if you're building your own version, because this is how we're going to make sure that we have all of the right functions, all of the right like extra functions that we don't need to implement here that will make sure that this works with your Label Studio ML backend. The first method that you'll need is setup. Importantly, note that setup gets called every single time the model gets called, and so this is not a good place for you to implement your model. In this example, we use what's called a lazy init method to load our model on the fly when it's time. So we only have to load it one time unless the model changes. Another way you could do it is by importing the model at the top here and only having that run once, because then it won't be called every time the class is instantiated. We're going to skip a few of these functions. The next big function to look at here is predict. So every ML backend must implement this predict method. It takes in a list of tasks and any context in Label Studio format, and it returns a model response object, which we'll go over in a second. This is where all of your inference logic is going to go. So basically, this is the method that gets called when you click on that task in your Label Studio instance. It's going to get the information about your task as well as any information that your human has put in. So in some of our ML backends, you provide a key point on an image, and then we mask out the whole area that the key point has selected. That would be part of the context here. Basically, what you need to do in this method is just format your data from Label Studio into whatever format your model requires. In this case, we need a list of the text as well as any labels that we're able to predict on, and a threshold. Then you're going to go ahead and just make your prediction, however your model needs to make its prediction, whatever method you need to call. And then we'll convert that to Label Studio format, and we'll make a list of those extended predictions. And then the model response object goes ahead, takes in that list of predictions, and returns it to Label Studio. It sounds more confusing than it is. I promise that once you sort of get into the workflow of this a little bit, it's much, much easier to do. But if we go ahead and take a quick look at that convert to Label Studio annotations method, excuse me, you can see that what we're doing here is we are taking the GLiNER output format and we're putting it into Label Studio annotation format. So we're going to go ahead and create this from name to name type value dictionary, which is the format that Label Studio expects its predictions in. You can get more information about Label Studio predictions in our documentation. But you're essentially going to create this kind of dictionary. You're going to provide a score, and then we're going to make a list of the results that have this prediction value type. And that's all there is to it. And then finally, in this method, or in this object, you could implement, if you wanted, a fit method, which allows for on-the-fly training of your model directly from Label Studio. In this case, we have it set up to trigger only when the start training button is pushed, which is over here. If we go back to our settings in our model, if we click on the little three-dot menu here, we can go ahead and start training, which is how you would trigger this action. And essentially what this method does is if start training has been called, we pull all of our labeled tasks, we format them into the right format for our training data set, and then we go ahead and we make our training arguments and we call self.train. The benefit of the ML backend is that this is all completely configurable to whatever kind of model you are using. So if you're using a model like GLiNER, you might need to do some text formatting. If you're using an image-based model, You might have to do some image processing, but it's really, really customizable to whatever it is that you need and whatever it is that you want to predict. As we saw with the YOLO example, you can predict more than one thing at a time if your model is able to handle that. You could also use the ML backend as a wrapper around a hosted model somewhere else. If you wanted to like host your model in the cloud somewhere, you could use this as like an API wrapper to call to that model. So without further ado, let's walk through what this process really looks like in practice. So we're going to go ahead and we're going to move to my GLiNER folder. I'm just navigating in my, I've already git pulled my ML backend Git repository here. So I'm in the GLiNER object or in the GLiNER folder, which looks like this. To run it, all we need to do is run Docker, is first you need to update your variables, which I've already done. And then we can go ahead and run Docker compose up on this folder. You can see it's already connected. It's doing all of its utilization, and now it's listening on port 9090 on my local machine. We're going to go ahead and use the same ngrok link as before because it's already been running on my local machine. And we'll go to this project that's just doing GLiNER. GLiNER is an NER model that looks for publishers and dates primarily. So our text is just the New York Times 2024. Pretty straightforward for this example, but you could use whatever you wanted. We'll go to our settings. We'll go to our model. I'm going to disconnect this model so that we can show you how to run it from scratch. You'll see this screen. We'll go ahead and connect our model. We'll call it GLiNER. You could, of course, call it whatever you want. From there, we will go ahead and give it the backend URL that we used before. We don't need any authentication in this model. We don't have any extra parameters in this model. Interactive pre-annotations is how you would go ahead and be able to pass a context with it. So without interactive pre-annotations turned on, the model will automatically be called as soon as you click into an example. If interactive pre-annotations is on, it's going to wait for some sort of human interaction, maybe a key point, something like that. That's what will happen there. So we'll click validate and save. It's going to make sure that, I don't know why it didn't run. That's weird. That's never happened before. Let's try that again. GLiNER, give it the backend URL, validate and save. I've never had this issue before. Let's see what it's doing. Looks like GLiNER is running. We can click into it. Nothing has happened. This is what I get for the demo gods not being on my side today. It was working this morning. I tested it. GLiNER, give it the backend URL, free app. That's probably the problem. Validate and save. There we go. Now it's connected. And we can go ahead. You can see that the model is being triggered on our backend. This is great for debugging if you're debugging locally. And if we go ahead and click into this, it's going to load our model. It's going to make some predictions. And you can see that we've gotten a publisher and a date here. And just like in the YOLO example, our predictions from the model are available here, GLiNER model v0.0.2. We have a publisher and a date. These are not editable. And then in the Micaela tag, I could go ahead and make any edits to this that I wanted to make. Maybe this is a publisher. Maybe I want to call it an organization instead of a publisher, whatever. And then I can go ahead and submit that. It is important to note, if we go ahead and take a look here in our data manager, if we scroll over, we can click on the task source button to see what the task source will look like. This is the same as what you'll see if you were to download your data. You can see that we have the original text of the sample here. Annotations are what I have submitted. You can see here that the origin for this is prediction because I didn't make any changes. And this way we can know that the origin of the annotation is a prediction. We can also see the original prediction itself. So if you had made any changes, you'd be able to see your annotation as well as the original prediction side by side. This is great if you're trying to do some sort of model evaluation task or if you're trying to retrain a new model. And that is the ML backend in a nutshell. Pretty easy to configure, pretty easy to host. Again, if you go to our examples repository, you can see all of the ones that we've updated and that we've built recently. This is a living, breathing repository. So if there's any model that you would like us to implement, please let us know. I can't make any promises about what we'll be able to do, but it's certainly an option. And as new models come out, we're always interested in helping others be successful with the ML backend. So with that, I will take a pause. And I see some questions in the thread. So I'll go ahead and answer those. If you have any other questions, please drop them in the Q&A section or in the webinar chat. So I've already addressed these. Will the recording be shared? Yes, it will. It will be on YouTube as well as probably emailed to you. Nate, you can confirm that.
Yep, 100%. This is all
Great.
recorded, and we will be sharing it within the next 24 hours, I would say. So
Perfect. Thank you so much. Can we expect upcoming MCP integration so as to use Claude Desktop or similar to help automate the process for on-prem localhost users? That is a great question. The answer is sort of yes. Nate, was that a hand?
that was a mistake.
Great.
Apologies.
No, all good. So we are in fact working on an MCP integration right now that will allow you to mostly build projects and work with projects from Claude Desktop or similar. That should be out in the next week or two. I don't know that we're using MCP right now with the ML backend, but it's certainly a great idea and something I'll bring back to the team. So hopefully that answers your question, and hopefully that will be helpful for you. What other questions do people have about the ML backend? Someone asked earlier if the ML backend is available in the community edition. The answer to that is yes. The ML backend is in fact available in the community edition. Does it support video annotations? It absolutely does. So right now, from our video capabilities from the pre-built ML backends, we have segment anything to video, which does video annotations, as you can see in this image or in this video GIF. We select a player, and then we use SAM2 to go ahead and follow that player. So that works out of the box. We also have YOLO integration. Our YOLO annotation does also support video. We can go down here. The video tutorial is not a GIF, it's a video, but you could watch it if you wanted to. And we provide a labeling configuration that will work for this, as well as any parameters you might need to make video work with YOLO. So hopefully that works. Could the segmentation model be changed to another model from SAM? Absolutely, it could be. In our particular instance of the SAM integration, it really is meant for SAM, but you could definitely use the SAM integration as a template to build your own segmentation model to anything that you wanted from SAM. When getting predictions from a model, is there a way to also get probability assigned to a prediction? Yes, there is. So if we go into our YOLO example, I think we have it implemented in YOLO, but I'm not positive. If we click into our example, you can see here it's a little small. We do have a confidence score provided by the model that is shown right here. And that is something that you passed as a parameter to the model, or as a parameter when you do your processing of your data. So that's very easy to add. What about complex labeling structures? Does it make more sense to have one YOLO backend model for everything or to have specialized models? That's a great question too. Ultimately, the answer to that question is going to come down to what your latency expectations are. Unfortunately, you can only connect one ML backend to each project. So it makes a little bit more sense to have one YOLO model for everything. But if you want to have specialized models, you could, of course, build a backend that talks to all of those models at the same time. So it's really up to you as to what kind of performance you're looking for, what kind of model you're looking to use. In the case of YOLO, I would suggest using just one YOLO model. But depending on what your project is, could depend on whatever it is that you're looking to do. You can see that in this other example. You'll see if it works. Again, I'm not positive that it will. Oh, this model is not running. This is not going to work at all. But you can see that we've predicted the the squares here. Could I show again where the ngrok tunnel is set? Absolutely. Ngrok is set on my local machine, so I will actually go ahead and turn this off for a minute. You can see that I just, in my Docker, or my console terminal, I just run the ngrok command, ngrok http, with the http localhost 9090 command. Setting up ngrok is really easy. Their documentation is very, very clear, but that gets run wherever you're hosting your Docker container. So if you're hosting your Docker container locally, ngrok will get set locally. If you're hosting your Docker in the cloud, ngrok will get set in the cloud, et cetera, et cetera. If you are hosting a model in the cloud, which we have done for some of our like SAM examples, make sure that you host it on the port that is exposed, unless you're also running Label Studio inside the same closed system. I hope that makes sense. What kind of URLs can be used to host files for the ML backend? Can you clarify the option of hosting files locally for the web-based human signal application? Sure. The ML backend needs access to your file. If you drag, so in this particular instance, I have just dragged the, I've gone to import and I've just dragged my files from my desktop directly to the cloud, and Label Studio can access those there. If you're using cloud storage, this should also work. And that is really what it comes down to. We have a lot more documentation on this that can explain better hosting files locally. But you can also set in your settings, if you wanted to connect cloud storage of some sort, you could connect it there as well. So that is done. Alrighty. When you activate training, where are the models stored? They run in the Docker container, so they're good strategies to persist or version them. That's a great question. When you activate training, the models are going to be stored on your Docker container. So the strategies to persist them, I would recommend either copying them to the cloud and using them there. It has better versioning than most Docker containers do. But you can also use just like a named file system. So in the GLiNER example, what we do is we look for a stored version first, like a pre-trained version first. And if that exists, we load that. And if not, we load the original base model. It's really going to depend on what kind of model you're using and where your base is from as to what's going to make the most sense in terms of persisting and versioning them. And if you are storing them in S3, you're going to have to deal with like connecting your Docker container to your S3, and that can get a little complicated. So I would recommend it depends on your use case, which is not a great answer, unfortunately, but hopefully helpful. Is CUDA and MPS supported if available? Yes. So in most of our examples, that's going to come down to your Docker container. But there are Docker containers out there that can support CUDA and MPS. You just need to make sure that you're using one, and then make sure when you call your model that it's looking for those CUDA drivers. Getting CUDA to work on Docker can be a little bit complicated, but there's plenty of documentation online to help with that. Let's see. Brian, if you could ping me directly in Slack about your question, that would be really great. I'd love to talk to you more about that offline. And yes, recording will be available afterwards. Any other questions about the ML backend or anything that we've shown today? Great. Well, with that, I will go ahead and wrap up this webinar. Thank you so much for attending and for asking so many lovely questions. Again, if you need support in your ML backend creation or use process, I would recommend going to the community Slack and looking in the ML backend support thread. I'm often around there, as well as some of my colleagues who can often help you with that. You can also check out our discourse for great help there. Happy labeling and good luck. Have a good day,
Yeah.
everyone.
Thanks so much, Michaela, and thanks everybody for attending. And we'll get this recording off to all y'all. So thanks so much for attending.